Hey there, my name's Daniel Allen. This is Lab 2. There's a lot to go over in this lab, so I'm going to try and make it quick. Here are all the files, lots of digital files. Only two of them are exported to Verilog, which is the 4-bit mux, and the ALU. And so this is the 2-bit mux. So this is very simple. I don't even really need to explain this. The 4-bit mux uses 4 of these 2-bit muxes. So I have a simulation here set up, so if we've got 5 and 2, it's going to show 5. It's going to show the A input. These are both 4-bit inputs. This is a 4-bit output. So it's going to show A. If I flip this, it's now going to show B. I can change this to like 1, right? It's still going to show 5. Unless I flip it, then it goes to 1. Okay. I'm going to show the the 4-bit mux display is the same exact thing, but with just displays. So 2 and 1, right? Toggle between 2 and 1. Let's see. I guess just the ALU. So the ALU, well, okay. No, we're gonna open actually the and add, or no, we'll open the not negatives. So this is also a very simple circuit, just 4 input data bits, 4 output, right? You've also got this, and then the you can invert, negate, put in 1, right? If I invert, just inverts that. If I do invert and that, then it increments it because of the incrementer. I will then go to the and add, which is a bit more complex, uses 2 4-bit muxes and a 4-bit adder. Okay, so this one, if I have, say, 5 and 2, if I add them, right, so if I choose to add them, it's going to use it's just going to use this 4-bit mux. If I add and then sin, right, it's going to add 1 to that. The pass toggles the other 4-bit mux, which toggles A. And yeah, so it just does a bit of math and then also uses some of the functionality from the 4-bit mux. ALU uses both of those circuits that I just showed, so that's why I opened those. So the ALU, let's have 5 and 2 again. We're going to invert it, right? So that's going to show 5 is going through here, but now A is going through. If I decide to do arith, right, that's going to add them. If I pass, right, it's going to show 5. Invert is going to show 2, right? So that's how we show both A and B, and then there we go. So that's going to add 1 again. And I'm going to show this in GTK Wave. So I have both of these. Both of the ones that I exported to Verilog, both in GTK Wave. So I did set up test cases for these, which are in this. So I have them all listed out, so I don't have to open that file again. So here are all my test cases, right? So for test case 1 for ALU, we've got arith, invert, and pass all at 0. That just does A and B, right? So A and B is just going to be F. Or F and 0 is just 0. Right? A and B is 0. F and 0 is 0. We got now number 2, which is y equals A equals 9. So that's with 0, 0, 1. So arith invert pass with 1. That's just going to show the value of 9. A, we got this. I'm only going to go through a couple of these just because it's a lot. But arith 0, invert 1, pass 1. So invert is now going to make the output 0. So if I were to, let's see, make this hex, we do A, then we do, right, just invert, right, it's going to do not A, it's just A's complement. You see if I pass, right, that's going to do A. So, like, that's what happens here in 0, 0, 1. If I were to just do pass, it just passes A. 0, 1, 1, right, so it's going to be invert and pass. It just passes, because you see invert is the 1's complement, so then you pass the 1's complement. So that's the one that equals 5, right? Yeah, so that's I mean, that's basically how it all works. All of the pictures are in here. I didn't really have any troubles actually designing the circuits or simulating them. It's a little difficult to explain them sometimes, but I have an understanding of how it works. It's just a lot of information to go over in such a short video. I don't want to make it too long. But yeah, again, my name is Daniel Allen. This is Lab 2.